In this problem, we're asked to find the momentum stored in the fields if we have a parallel plate capacitor, and we set this parallel plate capacitor into an external magnetic field. The magnetic field is going to point in the positive x direction, and we know from the parallel plate capacitor, right, that we're going to get a field in the minus z direction. So let's go ahead and just write down what the E and the B for this system are. I have a parallel plate capacitor, so I know that the E field is going to be 0 outside, and inside is going to be Q over A epsilon naught inside, and this will be in the minus z hat direction, and 0 otherwise. I have already been given B, and so to find the momentum, I just use the expression for momentum density in the field. So momentum density in the field is, by definition, epsilon naught E cross B. So I go ahead and I plug that in, and the momentum density in the field is going to then be QB over A. And then the cross product, so minus z cross positive x will be in the minus y hat direction, so minus y hat direction. And so that's the momentum density. If I want to find the momentum, right, P total, I then integrate d3x times little g, P total. This d3x, right, is going to be area times this distance here, delta z. So area and delta z, the areas will cancel, and so the P total will be Q B delta z in the minus y hat direction. So I'm going to pause here for just a moment because we're done with this problem now. But I want to point out that this actually tends to tell us something. This tends to tell us something about what the magnetic field is. The magnetic field is something somehow related to momentum in charges. So that's kind of neat. It gives us a hint that magnetic field is somehow related to the momentum in charges. Interesting.